Hello everyone, and welcome to Ask Tom Database Security for June 2020. This month's topic is Kerberos Authentication. You'll notice I've got it subtitled Integration with Microsoft Active Directory. Although Kerberos can work outside of Active Directory, the majority of the implementations we see are focused around Active Directory integration. And so we won't be talking about pure MIT Kerberos in this session. We'll be focusing on Active Directory Kerberos. As always, whenever we discuss future features or products, those are just plans. They may or may not come to fruition. Just sort of keep that in mind. You should always base your decisions on what a product does right now. A reminder that this call is being recorded, and the recordings will be available on the Ask Tom website, usually within a week or so of the session itself. Ask Tom is intended to provide you a direct channel into database security product development. We give you an open forum where you can ask questions you can't get answered somewhere else, and each session follows roughly the same format. We'll start with product announcements. We'll produce some technical content. This month we're talking about Kerberos, and then at the end of the session we'll open it up for questions and answers, and your Q&A is not limited to the technical topic. Anything is fair game that has to do with database security. We do 2 of these sessions each month. The content in the 2 sessions are identical, so the only difference is what questions get asked, but you don't have to attend both to find out what's going on, just attend one. Let's move to announcements. First one's a big one. We have extended support for Oracle Database 19c through April of 2027. That means that if you were to migrate to 19c now, you are good for almost 7 years, just short of 7 years, before you have to worry about migrating again. This is a long-term release. It is what we expect customers currently on 11G or 12C or 18C to go to in the next couple of years. And the next release after 19C will be what we call an innovation release. Innovation releases are short-term releases. 18C is an example of an innovation release, so was 12.2. Innovation releases typically don't offer extended support. And again, the expectation is most of our customers will be on long-term releases, only on innovation releases if there is a feature in that innovation release that you need for production. Another product announcement this month is the release of Key Vault 18.4. A lot of new features in Key Vault 18.4. One of them is the console timeout. In the past, that was a fixed value. When you reach that value, the console would just time out. Now you can update that timeout value to whatever your organization's standard is, and following timeout, you're now redirected immediately back to the login page so that it's obvious you've timed out. We've improved our hardware security module compatibility. Key Vault adds in support for token labels. On Italis Luna, that means that we now have support for Luna partitions. For Encipher, you can now enter the passphrase for an Encipher smart card. We have expanded the list of HSM vendors that we support, and Utamako now joins our supported HSM vendors. To upgrade to 18.4, if you've got an existing 18 installation, you'll want to download patch 313-47178, and that's how you'll do your upgrade. If you want to install a new OKV 18.4 server, go to edelivery.oracle.com and search for Key Vault. And if you're working in the Oracle Cloud, we have already updated our Marketplace image. Go to the Oracle Cloud Marketplace, search for image type. The type of image is image, publisher is Oracle, and the category is security. A few more things on Key Vault 18.4, just because there's so much there. We have expanded our support for credential files. Credential files in Key Vault are offline. In other words, they're not serviced directly, but we provide a place to escrow those so that they can be retrieved for later use. That does include Kerberos key tabs, which we'll be talking about a little bit later on today. We've added a couple of new REST API commands, and a really exciting new capability that you'll see in 18.4 is the ability to store passwords for database accounts in Key Vault, and then retrieve those passwords for use in batch or cron jobs. What this means is Instead of having your passwords hard-coded into a batch script, or instead of having a local secure external password store wallet residing on the database server, your database server subscribes to the password in Key Vault. When you change a password in a database, all you have to do is update the stored password in Key Vault, and every client of that password gets the new value immediately. There's a lot more in Key Vault. Take a look at what's new in the Key Vault Administrator's Guide. One quick note, this new use case around password storage, we do not have that in the documentation yet. We're still working on cleaning that up. We expect to have that documentation out soon. Look for it in the coming weeks. In our Oracle Support Corner, this month's topic is Kerberos. I polled some of our really top Kerberos support reps about which notes they thought were most relevant for supporting Kerberos, and they unanimously told me that this note 1304004.1 was the reference that they would steer customers to. Now, I've taken a little bit of a liberty here. The actual title of this note is Configuring Kerberos Authentication with a Windows 2008 R2 KDC. I replied back to them, surely if it's 2008, it's too old to be relevant. And what they told me was, no, this, despite the name, it's updated frequently whenever new issues are discovered. This is the definitive reference for support for Kerberos. I've suggested they might want to remove the Windows 2008 R2 from the title just to make it more obvious it's not an old note. We'll see if that occurs or not. But for now, keep in mind 1304004.1. This is your main reference. You'll see several others listed here on the screen. And with that, let's go ahead and move to our topic for today, which is Kerberos Authentication. Kerberos isn't an Oracle product. It's not unique to Oracle. Kerberos is a industry standard protocol that is used to allow different resources to communicate each other in a secure fashion. Before we get too far into this, there's a few terms that I want to go over with you just to sort of set the stage. The first one is the idea of a Kerberos distribution center. The Kerberos distribution center is what serves up Kerberos to clients that subscribe to it. It produces things called tickets, which are authentication tokens. It sets policies on how those tickets are going to live. Examples of a Kerberos distribution center would be an Active Directory domain controller. Active Directory uses Kerberos under the covers. But you're not limited to Active Directory. Kerberos is an open source project. It came from MIT, and there are, it's perfectly acceptable to go out and stand up your own MIT Kerberos server just for authentication. Within Kerberos, there's three concepts you need to be aware of. There is a realm. A realm is a grouping of systems serviced by one or more KDCs. In the Active Directory world, you can usually think of the concept of a Kerberos realm and an Active Directory domain as equivalent. They're not exactly the same, but they usually look to be about the same. Another concept is the concept of an entity. This is a resource or actor. In other words, it's something within the realm. Now that could be a user. Every user is an entity. It could be a host computer. Every server is an entity. Or it could be a service. For example, Oracle databases are an example of a service that would exist within a Kerberos distribution center. And finally, there are principals. Principals is kind of the intersection of the realm and the entity. It is how an entity is identified within the realm. There is a specific structure to a principal, and there are three different types of principals. There are user principals, and for user principals, the structure is username at realm name. There are host principals, and for a host principal, the structure is the keyword host with a slash, then the server name or the host name at realm name. And finally, there are service principals. A service principal is the name of the service, Oracle, the name of the server the service is running on, in this case RustDB Sec Lab, at realm name. So these are our concepts that we're going to be building on for the rest of today's session. Now, give you a quick trip way back in time. Kerberos has been around at Oracle since Oracle 7.3, so we're going back to the 1990s here. We first introduced Kerberos support in Oracle 7.3. Back then it was part of the Oracle Advanced Networking option. Kerberos initially was not used by a lot of people. It was getting a lot of industry buzz, but it wasn't very commonly adopted. That all changed in 2000 when Microsoft released Windows 2000 and adopted Kerberos as its underlying authentication mechanism. Kerberos at Oracle remained a part of an extra cost option until 2014. And by 2014, Kerberos had become so commonplace that it no longer made sense for it to be an extra cost option. And we moved it outside of what was then called the advanced security option to the standard database. So just like other technologies that have been commonplace, network encryption, enterprise user security, certificate-based authentication, Kerberos authentication is no longer an extra cost item. It's just part of your database. Today, if you're not using password, Kerberos is the authentication mechanism you are most likely to use. Password is still the most common, but Kerberos is the second most common. Again, in Active Directory, domain controllers are also Kerberos distribution centers, and therefore Kerberos authentication is a great way to integrate with Active Directory. It is one of the easiest ways to integrate with Active Directory because unlike other methods of integration, there's no requirement to install password filter plugins or DLLs. There's no changes required to the Active Directory schema. Kerberos is native to Active Directory. And so we see it used a lot, both purely as an authentication mechanism for the database and also in combination with user management frameworks like enterprise user security and centrally managed users. What you'll see here is an example of a Kerberos ticket that was retrieved upon login to a Windows client. As soon as I log in to any Windows client that's a member of a domain, I get my Kerberos ticket and I'm now ready to begin talking to Kerberos services. So let's go ahead and look at Kerberos, and we're going to do a quick demonstration. And when that's done, we'll dig more into implementation of Kerberos. Here I have two clients. On the left-hand side, you see a Windows client, and this workstation is part of an Active Directory domain. On the right-hand side, you see a Linux client, which obviously isn't part of an Active Directory domain, but does have the Oracle software installed on it, and Kerberos has been configured on both of these workstations, and of course on the database. On the Windows side, if I check to see if I have a Kerberos ticket, yes I do. I was granted one when I logged in, and I can see that my user is R. Lowenth and my Kerberos realm is dbseclabs.com. On my Linux side, if I do a quick check and OK list, I do not have a ticket because I have to go get one manually. And so I'll run OK init and give it my Active Directory username, and I'll give it the password in Active Directory. And now when I run OK list, I do have a Kerberos ticket, and I can see that the principal here, rlowenth at dbseclabs.com, matches the principal that I got on my Windows workstation. To use these, I'll just say that I want to do // because it's external authentication, @ and then the TNS alias PDB1. Quick show user, and I have connected to the schema Rus. I do the same thing on Linux. Show user, and sure enough, I'm connected to the same schema. I've also enabled my SQL developer with the same configuration, and there, when I check, I can see that the Rus schema has been authenticated to using Kerberos as the Kerberos principal, rlowenth at dbseclabs.com. You may want to remember these two user environment variables, authentication underscore method, that's what tells me I connected via Kerberos, and authenticated underscore identity, that's what tells me the Kerberos principal that I connected with. That is Kerberos in action. Once I've got my ticket, I can connect to any Kerberized resource as long as it understands that ticket without having to do anything else. All right, so again, what we did was we looked at Kerberos from two different client standpoints. On a Windows client, where the Windows client was a member of the domain, I already had a Kerberos ticket because that just happens automatically. And all I had to do was make a connection to my database, which had already been set up for Kerberos, and I'm logged in as my user, as my Windows principal. On the Linux client, because Linux is not using Kerberos for login, I had to first retrieve a Kerberos ticket, and I did that with the OK init command. Once I had my Kerberos ticket, I could view it with the OK list command, and after that I could simply log into the database and continue on, and just as if I were coming from the Windows client. So this is how Kerberos works, and it's kind of the idea of Kerberos. Once you have your ticket, for the lifetime of that ticket, all resources that support Kerberos are open to you. It's kind of like single sign-on in a way for everything that's within that Kerberos realm. All right, let's look at implementation. There are a lot of moving parts to Kerberos. On the Active Directory side, we have the standard Windows user. Every user who logs in gets a Kerberos ticket. We also have a service account, a user that we will create in Active Directory for the database server itself. This is what we're going to assign the service principal that we talked about earlier to, so that databases can be authenticated via Kerberos. So on domain controller, two very simple things: standard Windows users and service accounts. You always have the users anyway. On the database server, there's several places that we need to do work. One of those is we're going to have to make some updates to the SQLnet.aura. We're going to create a new file called a krb5.conf. We'll go into each of these files here in a little bit. We're going to retrieve something called a key tab, which will be generated on the domain controller, and we'll put that on the database server so that the database knows what its service principal name is. We have the etc host file, or DNS, which describes where, does IP address to name resolution. We'll have etc services, which you may or may not have to change. And finally, within the database, we will create users that can be authenticated via Kerberos, and those are externally authenticated users. Now we shift to the right-hand side of the screen, and we're going to look at the database client. Just like on the server, we have the SQLnet.aura, the krb5.conf, and the services file. We may have to manually retrieve a Kerberos ticket if we're on a Linux or Unix client, or if we are on a Windows client that is not part of the Active Directory domain. Okay, but these are our moving parts. Let's dig into these, and we'll start with the krb5.conf file. This is an example of a krb5.conf file. There are three sections here, and you'll see them in brackets. The format of this file is critical. If the format is not just right, you will receive errors. They're very obvious errors, but this is the format you need to have. The first section is libdefaults. In libdefaults, we will always identify the default realm. This is anyone using Kerberos on the computer that has this configuration file. If they just give a username, what realm should that username be applied to? Basically, this is your Active Directory domain name in most cases. The next parameter is clock skew. Kerberos tickets are very time sensitive, and so this says how many seconds do I allow my client and my resource to be apart in terms of time before I say I no longer can trust the client, I'm just going to not allow the connection to happen. And the third parameter you see here is forwardable. Do I allow this Kerberos ticket to be sent to another server where it can continue to be used for authentication? You'll always see this used for database links. I typically will set forwardable equal yes by default. Next section down is realms. We define the Kerberos realm, and within the realm, where are the Kerberos distribution centers that we're going to send requests to? Now here, instead of listing, because I'm used to working in Active Directory, instead of listing each individual domain controller, what I will typically do is just put the domain name in my case dbseclabs.com, and the port 88 is the standard Kerberos port. By using the domain name, I allow the work of identifying which domain controller to go to be done at the DNS level. Because in a Windows environment, all domain controllers will register with DNS, and this is how Windows workstations identify what domain controller to talk to. They make a query to DNS, and they're directed to the proper domain controller. So this is usually how I will set up my realm, is just with a single line rather than trying to list each server. The next section, domain realm, is critical. This is what maps the server domains to the Kerberos domains, so DNS domains. So for example, if I have a server called bob.rust.com, I might want to send bob.rust.com to dbseclabs.com for Kerberos work. Kerberos is case sensitive, so we want to handle the case of both upper and lower case, and I'll usually handle the case of having a dot or not having a dot in the realm name as well. But again, this mapping section is critical. You'll find a lot of times that you have to go out there and update this as you get servers that are assigned to different domains within an organization. We move from here to our SQLnet.ora. You are almost certainly familiar with this file already. This is the standard Oracle networking file. We're just going to add a couple of parameters to this that say how Kerberos is going to work. The first one is SQLnet.authentication _ Kerberos 5 _ service. Now, I've used Oracle here as my example, and you'll remember when we were doing our terms and definitions, the service, that is what identifies the class of services we're working with. This doesn't have to say Oracle. It's an arbitrary text string. You could say database, you could say George, you could say Larry, you could use Russ if you wanted to. What's important is that whatever you use here is used consistently throughout your environment. So if you decide that your Oracle database services are going to be called Russ, then on every database server you want to use Russ, and on every database client you want to use Russ. And when you create your key tabs, we'll talk about those in a little bit, you want to use Russ when you define your service principal. Next line is Kerberos 5 _ conf. Here you're just pointing to where is that krb5.conf file that was on the last slide. Next parameter is authentication _ services. Here I'm showing that we have Kerberos 5 pre and Kerberos 5. We'll talk more about these on the next slide. We have clock skew again, and then we have Kerberos 5 _ conf _ MIT. This is a parameter that really no longer serves much purpose. We'll probably be getting rid of it in a future release of the database. If you go fairly far back in time, really before Active Directory became so prevalent, there used to be several different distributions of Kerberos, and so this was how we told the database which software library to use. Are we using the MIT library, or are we using another library? Anymore, it's always going to be true. If you don't have it set, the default is false, so if you don't have conf MIT set to true, Kerberos will fail, but it really no longer serves a purpose. We'll be getting rid of it soon. Next parameter is Kerberos 5 key tab. We'll talk more about key tab in 2 slides, but this is a permanent token that is issued by the KDC that identifies the assigned Kerberos principal for the database. Okay? Final parameter is the Kerberos cache name. In my case here, I've got it set to osmsft://. This is what I will normally use on a Windows client. That osmsft is saying to use the default memory ticket that I got when I logged into my Windows client. Much like authentication services, we're going to talk more about CC name on the next slide. Okay? Now, back to authentication services. Authentication services tell Oracle databases and Oracle database clients which of the many authentication mechanisms that are open to the database can be used for sessions using this SQLnet.aura file. BEQ is a special type of authentication service that is used for local OS authenticated sessions. These are sessions, bequeath sessions, that are not routed through the database listener. The classic example of this is if I say SQL+/assistDBA, I'm not routing through anything, it's not a network connection, I'm making a direct connection to the database, a bequeath connection. If I don't have BEQ in my SQLnet.authentication services, then /assistDBA doesn't work. And to connect to sysdba, I would have to say SQL+ sys at database alias as sysdba and then give a password. BEQ, although we normally think of it in terms of /assistDBA, is also used to authenticate local OS authentication. A really common example of this is if I create a database user Oracle identified externally, and then database is installed as Oracle, so I log in as Oracle, and I just say connect /, not with sysdba, just connect /, then that is the external connection. The database checks, yes, BEQ is authorized. What is your operating system user? Oracle. Do I have a matching account? Yes, I do. And you're in as Oracle. Very commonly used when the application server is running on the same server as the database. It's a great way to do non-routable connections, very, very fast transfers of data. The trouble is, BEQ is a form of external authentication, and Kerberos is a form of external authentication. So if in a client you have both BEQ and Kerberos identified as valid authentication services, the client will almost always choose BEQ, and if BEQ fails, it will not fail over to Kerberos. So in clients, I don't typically add BEQ. I will do that on the server, but not on the client. Next one we're going to go to is Kerberos 5. Kerberos 5 is the authentication service that we're going to use for Linux or Unix clients that are not using the in-memory ticket cache. The next one is Kerberos 5 Pre. This is the setting I'm going to use for Windows clients using the in-memory ticket cache. Let's take a quick look at these. Okay, here we have our Linux client, and if we take a look at our Linux client at the SQLnet.aura file, we can see that our authentication service is set to Kerberos 5. Which makes sense. We are using a file-based cache, and therefore we want to use Kerberos 5 as our authentication service. If we look at our Windows client, where we are using a memory-based cache, we'll talk more about this in just a few minutes, we are using an authentication service of Kerberos 5 Pre. Now if we look at our database server, what we'll see is that our authentication service is set to BEQ because we want to allow someone to connect /assistDBA. We accept communications from a Windows client using in-memory cache, so we're Kerberos 5 Pre. And we accept communications from either a Windows or Linux client using file-based cache, so we're set to Kerberos 5. So our database is set up to cover all eventualities. Our Linux client is set up properly, and our Windows client is set up properly. What this setup doesn't allow, remember this yellow here is my database server, is from the database server's Oracle home with TNS admin not set to some other directory. In other words, using this SQLnet.aura in Oracle Home Network Admin, I cannot do a Kerberos connection to a database. I have to make other arrangements if I want to do that. Now let's talk about Kerberos cache name. On a Windows client, cache name is pretty easy. I'm almost always going to want to use the in-memory ticket that I got when I logged in. The exceptions to that are if my Windows client is not actually a member of the domain, then I may want to not use the in-memory ticket because it didn't come from the right domain controller. But other than that, it'll almost always be the in-memory ticket. The CC name, you either set that to in-memory or to a file. The file would be something like c:/Rus/Kerberos/KRB5cc. That's an example of what you might set it to. If you don't set it at all, both Windows and Unix servers have defaults. On Windows, the default is to go to the user's temp directory, and the file name will be KRB5cc. On Linux, the default is to go to the system temp directory, and the file will be KRB5cc _ whatever the UID is for the user who drew the ticket. Now, I will almost never set Kerberos 5cc name if I'm using a file-based cache, because I like to let the operating system take care of placing the ticket where it will be automatically cleaned up, right? Because temp directories get automatically cleaned up. And I also want to make sure that if I have a client server that is a client workstation that is being used by multiple different people, I don't accidentally set up a case where two people on the server at the same time are conflicting with each other. So it's usually best not to set Kerberos 5cc name if you're using file-based cache. Memory-based cache. The value you're going to use most of the time is OS/MSFT://. And yes, you do have to have the colon and the 2 slashes. Again, only for Windows, this is what you'll typically use. There is an alternative value, MSLSA:, without the 2 slashes. We introduced this in Oracle 12.1. It sometimes works, especially in 12.1 and 12.2, but in most cases you're better off using OS/MSFT. Somewhere down the road in a future version of Oracle, we will probably dispense with Kerberos 5 Pre, and we'll just make Kerberos 5 work with everything for our authentication services. And we will probably dispense with OS/MSFT://, and we'll just get MSLSA to work with everything. But for now, this is what you have to work with. Let's look at some of those other files. We talked about the database key tab. Key tabs are issued to the database server, not to the database. And to create a key tab on the domain controller, or the Kerberos distribution center, if you will, you're going to use a utility called KTPass. And you're going to say what service principal do you want to put in the key tab. In my case, I'm using my service name, Oracle, my server name, rustdbseclab.dbseclabs.com, at my realm name, dbseclabs.com, and then which Active Directory account do you want this service principal to link to. A single Active Directory account can have multiple service principals linked to it. That's not a problem. But which one do you want it to be? And you give the user, in this case I just said George, and the password. I just said password here. Key tabs support different encryption types. I will normally produce it with crypto all. I'm sorry, my dash split lines here. What type of principal is this? This is an NT principal, this Kerberos principal. And finally, what do I want the file to be called? Database key tab. Once I produce that key tab, I simply copy it to the database server and I point to it in my SQLnet.aura. Sometimes I will have to make changes to Etsy services. This is most often an issue on AIX. Our implementation of Kerberos requires that we specify the Kerberos version. There's been several versions of Kerberos. We use Kerberos 5. The older Kerberos 4 is not supported. So when we're looking up the correct port for Kerberos in the services file, which is port 88 pretty much all the time, we need to see Kerberos 5. Not just Kerberos, not just KRB5, we actually have to see the string Kerberos 5. On AIX systems, you pretty much always have to make this update. On non-Oracle Linux distributions, you will frequently have to put this update in. On Oracle Linux, seldom. On Windows, very seldom. But just something to be aware of. You need to look for this if you're having problems finding the correct port. Okay? We have to be able to resolve the database server to an IP address. So you can do that either with DNS, which is probably the best way to do it, or you can do it just with a properly constructed Etsy host file. And by properly constructed, what I mean is I have the IP address, the fully qualified host name, and then the nickname, as you see on the bottom line here. Finally, we move to the database. Within the database, we create a schema. In my case, I called my schema Russ, and we identify that schema externally as the user principal that is going to be used to authenticate for this schema. If we look in DBA users, we'll see the external name shows that user principal and that the password is set to external. Now, quick note here, I mentioned this at the start. Kerberos is foundational. You can run with just Kerberos, and that's a great way to do Active Directory integration. But Kerberos supports centrally managed users and enterprise user security. If you are working with either CMU or EUS, instead of creating your user the way I've shown it here, or your schema the way I've shown it here, you would use create user Russ identified globally, semicolon. And at that point, what you're doing is you're allowing CMU and EUS to pick the correct Kerberos principal. Okay? Network connectivity, of course, has to be established. You need to make sure that your database server, in my case, my database server is 10.0.0.150. That server has to be able to reach the domain controllers on port 88. Your database clients also need to be able to reach the domain controllers. And in my case, I have one Linux client that is at 10.0.0.145, and that one needs to be able to reach the database client, the Active Directory domain controllers as well. Okay? Many of us like to use SQL Developer to connect to databases. I'm a terrible typist, and I find the easy way to go back and edit and rerun commands in SQL Developer very attractive. SQL Developer does support Kerberos, and it supports it in two ways. The first is through Kerberos thin configuration. And on the left here, you'll see right around the middle of the screen a little blue box that says Kerberos thin config. If you want to use the JDBC thin driver to connect via Kerberos, you're going to tell SQL Developer where the krb5.conf file is and where the Kerberos credential cache is. Now, SQL Developer does not support the in-memory cache. It doesn't support the automatic distribution of Kerberos cache files to my user's temp directory. So you have to name a cache file. This is really the only case where I will use a specifically named cache file is to support SQL Developer. A better way, at least I think it's a better way to support Kerberos and SQL Developer, is to have an Oracle client on the same workstation where you're using SQL Developer. And this has to be a true client. It can't be the instant client. But I'll simply point SQL Developer to the Oracle Home for that client installation, and then tell SQL Developer to use the OCI thick driver instead of the JDBC thin driver to connect. And after that, when I create my database connection within SQL Developer, I leave username and password blank, and I set authentication type to Kerberos. Okay? That's it for implementation. Now let's talk a little bit about troubleshooting. And just a reminder of all the different things that we've had to do to get Kerberos working. When you have a problem with that Kerberos, any of the things you see here could be the source of that problem. And so fixing a Kerberos issue is usually an exercise in detective work to track down where the problem resides. Is it on the domain controller, the database client, or the database server? If it's on the client or the server, which of the different pieces is causing the problem? And as you become proficient with troubleshooting Kerberos, network tracing will be your friend. Here what I'm showing you are the parameters I set up on the client to enable network tracing and the parameters I'll set up on the server to enable network tracing. I'm frequently asked, why do you use trace level server or trace level client of 15? It's because trace level 16 gives me more information, but the more information that it gives me is not information that I need. I know 16 is more commonly used, but I find it's a lot easier to read a trace level 15 file, and it just gives me all that I need. When it comes time to actually use your trace files, there's frequently a challenge matching the server trace file to the client trace file. You know, finding your client trace file is easy. You're on a client, you're the only person on that client usually. You do something, it generates a trace file, that new trace file is yours. But on the server, multiple people are connecting to it. And so during the time when you have tracing set on and you're making your test on your client, you may have 15, 20, 500, whatever number you want to pick, client trace or server traces generated. So your challenge is to figure out which of the server traces is your server trace. To do this, we're going to open the client trace file and we're going to search for connection space ID. When we find connection ID, there will be a string after connection ID. We'll then search the server trace directory for that string, and we'll find the file or files that match my client trace directory. Here's kind of a pro tip. If you're dealing with Oracle support, they're always going to ask you for server and client tracing. If you upload 500 server traces, then your support analyst is going to have to look through 500 server traces, right? And that is time that you would rather have them actually working on your problem than finding the right trace file. So do learn how to match the client and server traces. It'll make troubleshooting easier, and if you're trying to get someone to help you look at what's wrong with Kerberos, it'll make their lives a lot easier, make them a lot better able to assist you. There's a second type of tracing that is unique to Linux clients or Unix clients. If I set the environment variable krb5_trace to a file or path, and I then go in and do a Kerberos operation, like make a Kerberos connection, the system will automatically write a log of the Kerberos operations to that file or path, file and path, excuse me. And these operations, it'll tell me exactly what's happened during Kerberos negotiation. This is such a great troubleshooting resource that I will often create a Linux client even if I don't need one. But just for the value of having it for troubleshooting, it's worthwhile to have. A couple of other things to look for. Make sure you understand the Kerberos realm. Normally, the Kerberos realm matches the Active Directory domain, but not always. There are cases where the Kerberos realm and the domain won't match, and usually I found that is because at some time during the domain's history, it has been renamed. This could be just a company changed its name. It could be because of merger and acquisition activity. But what used to be Rust.com is now dbseclabs.com. So make sure you understand the Kerberos realm. Frequently, as you're setting up Kerberos initially, you will ask someone what the realm name is and they will tell you the domain name. May or may not be true. One easy way to see what the true Kerberos realm name is to go to a Windows client and just type in klist. What you see at the end after the username rlowent@dbseclabs.com, that's the Kerberos realm. Regardless of what the domain name is, that's what your Kerberos realm is for that user. Okay. Names resolution is important. Hopefully you're using DNS. Windows clients almost never have a problem with this if they're a member of the domain because they use the Windows DNS to find the domain controllers. Unix and Linux clients frequently have a challenge finding the domain controllers. Here what you're typically going to do is you're going to create a new entry that defines what is the domain and where are the domain controllers. In my example here, 10.0.1.149 is my domain controller, and you'll see I've got that listed as dbseclabs, which is my domain. Remember that Active Directory forests can complicate things. They're frequently complex. They'll contain multiple nested domains. Your domain trust relationship should handle that transparently. The only trick is getting the database to understand which KDC is used to service the different realms, and for that, the domain realm section of your krb5.com is where you're going to go for help. One more thing that we frequently see that can be frustrating when you're troubleshooting it is that key tab. Now, if I request a key tab from my Active Directory administrator, they'll run the command, they'll give me my key tab, and I'll get it. And sometimes I'll test the key tab and I'll find that the service principal that the database constructs, and again, we construct that service principal from the service name, which is in mysqlnet.ora, the server name, which is either what DNS resolves my IP address to or what's in etc hosts, and the Kerberos realm, which is from my krb5.conf file. I'll construct that service principal from those three components. Sometimes it doesn't match what's in the key tab file, and you will ask for an updated key tab file. Here's the challenge. Every time I ask for a new key tab file, that new key tab file is versioned. So when I get a new key tab file, that's a higher level version, and older key tab files are no longer usable. It's the way that we automatically expire issued key tabs. You can see what version your key tab file has by just doing an OK list, and you'll see here I'm key version number 3. You can see what version your KDC thinks your key tab file should be with the command kvno and the service principal. So here I've done kvno oracle @server, and what I get back is the correct key version number is 3. They match. When they don't match, you will have to create a new key tab file with the right key version number. And in the ktpass syntax, there is a way to specify what kvno you want the new key tab to have, but kind of look out for that. Now, here's a pro tip for you. That command I ran at the end, kvno, that is not a Windows command, that's an operating system command. But for kvno to work, it has to understand your Kerberos configuration. The default location for Kerberos configuration on most servers is /etc/krb5/krb5.conf. You probably don't have root access to write there, and so most of the time your krb5.conf is going to be an Oracle Home Network admin. To tell your operating system to use your Oracle krb5.conf, you'll set the environment variable krb5_config. You'll see that as the very first command that I ran in this example. Okay? Now let's have a little fun and let's break things. Off screen, I have gone through and I have introduced an error into my setup. And we're going to go through and see the impact of that. So we were already logged in from before. Let's log out on both the Windows and the Linux side. And we'll try to log in again. We still have our tickets. Okay. And when we over here try to connect, SQL plus at PDB1, we get an ORA 12638 error, credential retrieval fails. We try it on the Windows side. And we get the same error. So what we've got is a case where two different clients are seeing the same error. And that is my first troubleshooting clue. Since two different clients are seeing the same error, chances are good that the problem is not on the client side, but on the server side, right? Since we know this was working before, something has broken, it's unlikely that the same thing broke on two clients simultaneously. Now, ORA 12638 just tells us that Kerberos failed. It doesn't really tell us what broke, and you'll remember all those different things that could have been wrong. So we are going to go ahead and turn on client and server tracing, and once we've got client and server tracing turned on, we are going to try and do our connection, and I have already done that in the interest of time here, and here are my trace files. Let's first go through and we will look to make sure that we've got the right server trace. So we search for connection ID, and with the connection ID for this session is this string here. We check in our server, and sure enough, I'd already searched for it. We see that this is the connection ID in the server. So all's good there. We have the right client and server trace files. The error that we got was a 12638 error. So we look for that error, and here is the first place that error is displayed in the trace file. That means that the problem is somewhere before this, so we begin to scroll up. And what we're looking for is the first place where there are no errors. So we have an error here, couldn't get credentials, another error here, we have a failure here, we keep looking up, we have a failure here, we keep looking up. This is the first place we see that doesn't have any errors in it. So here's where we want to start looking for our problem. It's going to be somewhere right around in this area. And what we can see is that our client is R. Lowenthal, or R. Lowent at dbseclabs.com. We remember that when we did a K-list, this is what our user principal looked like. And we can see that our service provider is oracle/rustdblab.dbsecdemos.com at dbsecdemos.com. Well, that doesn't match what we had, right? Because we know that we're dbseclabs.com. So we go back and we check again. Sure enough, this looks right. Let's test our key tab file. So we'll do OK list -k database key tab. Well, this is definitely dbseclabs, not dbsecdemos. So one of two things are wrong here. Either the key tab is wrong, in which case I would have to issue a new key tab, or my names resolution is wrong. And if we check my server, which is 10.0.0.150, we can see rust dbseclab. Well, there's the error right there. So we fix this, labs, save it, and we go check again. Sure enough. And with that, we have troubleshot a Kerberos problem. So that's an example of troubleshooting Kerberos. Let's again review what we did. We had a problem, and that problem gives us an ORA 12638 error, which tells us that Kerberos Authentication has failed. It's not obvious what the problem is from the error message, so we collect client and server trace information. We examine the client trace first after validating that the server trace matches, and we look immediately for the error number 12638, and then we move up from there. We look at the place just above where the error started to occur, and we see that my client has a realm name of dbseclabs.com, but my server is dbsecdemos.com. And this is a mismatch. I either have to handle this mismatch in my key tab or in my names resolution. We check the key tab. We see that the key tab looks like it's constructed properly, but when we check what we're using for names resolution, which in my case was Etsy host, we can see sure enough I had dbsec demos in there instead of dbsec labs. We fix Etsy host, and voila, Kerberos begins working again. Okay? Now, a lot of moving parts here. When you have issues, it is often difficult for you to see your own typographical errors or your own mistakes. It's just human nature. I've done hundreds of Kerberos implementations, and I still have challenges with this. In fact, the error that I just showed you is one that I truly did, and I wound up phoning a friend who helped me spot my error for me. Kerberos has been around for 20 years at Oracle. Longer, but it's been around for over 20 years at Oracle. It is very stable. It's in use at thousands of customers. If you hit a problem, there's always the chance that the problem is a bug. It's possible. But it's much more likely that the problem is because you have made an error, usually a typo error, in your setup. So suspect your setup first. And remember, you often can't see your own errors. If you have someone you can call in, a coworker, a consultant, to look over your setup, they'll frequently spot the error you don't see because you're too close to the issue. If you don't have anyone you can call and you can't find the error yourself, Oracle support is very good at fixing Kerberos issues. Open a ticket. If it looks like you've gotten to someone who doesn't understand Kerberos, this sometimes happens, you may need to escalate the issue to ensure that you're actually assigned to the database security team for help on this. Sometimes Kerberos tickets will be routed to the wrong support team. So if you're working with a support analyst and it just looks like they're asking you questions that don't make sense based on what we've talked about today, then do reach out to your support manager and request that the ticket be assigned to the database security team. That's it for today's session. Our next session will be on Thursday, the 9th of July, and our topic is going to be data redaction. Data redaction is how we control the display of sensitive data. Thanks for your time today, and I look forward to seeing you on next month's session.